Section 12.5, surface area of prisms and cylinders. This puts together the last three lessons that we've done where we did area of rectangles, we did area of circles, and we did area of triangles. When you put areas of those three shapes together, what it does, it creates a three-dimensional shape. And as long as we're not doing volume, we will get to that, but as long as we're not doing volume, everything is still going to be something square, the same way that you were supposed to have everything squared in your homework yesterday. So we have name each shape as each part according to the textbook on this page. So what is the name of this shape? And don't say Philip. Okay. Hemkin? Rectangular prism. It's a rectangular prism. And the way that it's identified is going to be, I hope this doesn't erase, it did. It's going to be the part that is the smallest of the net. Now, a net is not necessarily something that we use in hockey, basketball, softball, hockey, basketball, volleyball, soccer, el fútbol, okay? Tennis. A net is whenever you have a three-dimensional shape and you unfold it to be on its sides. Okay, what identifies these shapes is going to be usually the smallest side that it is. If you were to stand it up on end, what would it look like? So here's an example of a rectangular prism. Here's an award that I won. Okay, this is a rectangular prism. Here's the smallest side, and that's going to be what it's going to be listed as. Okay, so it's going to be, so you could sit like that. But if I were to unfold this shape, it would be similar to that rectangular prism. Okay. All right. Ooh, get out of there. Ooh. This shape. What is the name of this shape? Schmidt. A triangular prism. That's right. Ugh. Get out of there. Ugh. Sorry, I can write better printing, so I'm going to do that. So the triangular prism, if I were to stand it up on this edge here, it would look like dirt, 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 dirt. Ish. Or if I set it on its side, bump, 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 bump. Like these. That's the passageway to middle school, I think. Okay, so that's going to be a triangular prism, and then we have una más. This here is going to be, yes, it's a cylinder, exactly, a cylinder. Is it cylinder? Thought so, okay, thanks. And the way that would work if it was standing straight up would be like this. Like that. Because we have a circle and a circle. You know, I'm going to leave that because this is going to be the one that I'm going to save for the website. Do this one. Do you agree with that a little bit? Yeah. Should I make that the side a little bit thicker? Would you be able to look at that and be like, oh, I know what he was doing there? Was that a good look? All right, now here's what's going on here. Edges. Edges are where sides meet. Vertices where edges meet. Faces are between edges. Edges are where sides meet. Farmers only is where farmers meet. Right, is that what it's called? Yeah. Vertices are where edges meet. Faces are between edges, and ruffles have ridges. So I'm going to do some vertices as being orange. These are vertices because that's where the edges meet. Oh, there's some more. Then we have some edges. The edges are blue. And then we'll do purple with faces. Just kidding. There we go. Somebody got it. Somebody got it. Get it? I drew faces. I drew faces. Yeah. So faces, I'm only going to do. I'm going to do them and I'm going to erase them. Okay? Because here's a face. That'd be a front side. Here's a face. There's a face. Okay. Then there's a face underneath here. Then there's a face behind to the side there, and then there's a face behind back there. There's going to be 6 faces. So here's, I guess I could do, yeah. So where are the vertices? Let's do this. Let's have some fun with this. Luke, how you feeling? Good. Come on up here. Identify the vertices in that triangular prism, please. I already have it as orange, I hope. Cool. Yes, sir. Good. He's feeling better. All right. Now, can I have someone come up and identify a couple edges being edgy? Let's get a female. Oh, I've been calling a lot of guys today, so Potter, then I'll have you do a couple faces, okay? Probably like a smiley face, a scared face, and then maybe like a confused face. No? Okay. Beautiful. So those are the edges. And what are the edges again? What? How do you identify edges? How is she doing that? Yeah, how is she doing that, Britton? Where the sides meet. Good. Yep. Go ahead and hand that off to Ms. Potter. Take it back. She's got a face there. She's got a face there. Here a face. There a face. Everywhere a face, face. How many faces are in a triangular prism, everybody? 5. For those of you chanting 5, you are correct. Yeah, it is 5. Look how many faces that Potter wrote on there. That's good. Potter wrote 5 faces. 5 faces. How many faces are there on a cylinder? Okay. We got 2. Hold up. How many think it is? We got some 2s. We got some 3s. We got a 7. Just kidding. You guys all look around. Yeah, it's 3. 1, 2, 3. Top, bottom, side. Top, bottom, side. They have no vertices, but they do have 2 sides, or they do have some edges. Were edges blue? Yeah. Those are edges. Yep. Think of. Does anybody have soda can on them? No.
I would have had one if you're allowed to have soda in here.
Well, you're not allowed to drink it. If you're transporting it to lunch, I'm okay with that. Good. All right, moving along. This one here. To find the surface area of this object, we're not going to do it right now. We did it last period, but we're not going to do it right now because I want to get through this. To find the surface area of the, yes. Yes. To find the surface area, would you like one? Okay, cool. I thought you were just double checking. We would have to look at how many lengths times widths we have. That's what we would have to look at. How many length times width? We're looking at all the length times width. And the thing is, surface area is length times width of all sides. Length times width of all sides, as you need to write in there, okay? Those are some good brackets. That's a talent. You should go pro. Colligan? Ah, yes. Length times width of all sides. You need to look at all the length times width, all the sides. Ooh, that was close. Length times width of all sides. On this one here, it would be different sides. You need to pay attention to how many different flavors of sides we had. Does that erase what it does? Okay, we need to look in different, how many different sides do we have? Because we have the back and the front, and we can consider this back and front like that. So that would just be length times width, and we're not going to put those values in because we're going to do that in the examples that we do here in a minute. Then we have top and bottom. We can have this be considered top and bottom, sure. That's also length times width. Then we also have the sides, which is going to be the length times the width of that times 2. So it's going to be 2 LW 2. Yep, fine, we'll do it. We're not going to work it out, but we'll do it. So the front and the back is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7, 8. So 7 times 8 times 2. The top and the bottom, sorry, let's front and the back, top and bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2 times 8. See how I'm doing this? Length times width times 2, because there's 2 of them. There's 2 of them, because it's going to be the same exact side as its opposite side, because it's a rectangular prism. Then we have the sides. Lastly, we already had the 2. Then it's going to be 7, right? 1, 2, 3, 4, 5, 6, 7. 2 times 7, twice. Yeah. Then this one comes out to be 172 units squared. 172 units squared. Yep, this whole unit you can use calculator. So then we have this one. We have the front and the back times 2, which is just going to be the length times the width. So it's going to be length times width times 2. Bottom times the top is going to be length times width times 2. The sides are also going to be length times width times 2. LW 2 LW 2 LW. Now those are not all the same lengths and widths. You got to keep that in mind, okay? They're not all the same lengths and widths. That's why I'm not going to add them all together and just have it be 6 LWs. So then we have a triangular prism. Now this one's going to be a little bit different because we have a back and a front. The back and the front, we're going to have the front be considered this side here. Like if this was a ramp and there's a cyclist going up it, right, so that he would jump off. I don't know. So that's what he'd be going off. So that would be the back and the front. Okay, back and the front. Now we're going to assume that this is not an equilateral triangle. Okay, we're not going to assume that this is an equilateral triangle. All right, it's not that. So we had the front, or the back and the front is going to be this guy, and that's going to be, if you remember, 1/2 base times height. 1/2 base times height, and times 2 is just going to make it be base times height. And the bases are going to be, I changed my mind with that little drawing there. The bases are going to be how it's sitting on the bottom here, and that's just going to be length times width. Darn it, I messed it up again. It's going to be length times width. That's going to be this guy. That's going to be the bases, that one, and the one in the back behind it. So it's times 2 because there's 2 of them, and then the bottom, since it's not an equilateral triangle, is going to be just the length times the width again. And you add them all together, and that's how you get the total surface area of it. Times 2. Length times width times 2. See how we're just making sure we account for every side? When you're doing this, you want to just make sure you're accounting for every side. Sophia, are you with me? Yes?
Wouldn't the bottom should be the length times width, not times 2?
Yep, you're right. Thank you. Then total surface area is going to be added all those together. Now this one here took a little bit of explanation to my previous class. So I have a cylinder here. Imagine that this is covered up. And for those of you that aren't in this room right now, what I'm doing is I'm covering my water bottle with a piece of paper so it looks like a cylinder. So here's my cylinder. As I find what the top and the bottom are, how am I going to find what the area of this shape is? What's the shape here? Okay, it's a circle. So what's the area of a circle? Okay, what is the area of a circle? You just did it last night. Or you just did it last night. Yeah. Radius squared times pi. So yeah, radius squared times pi, or pi radius squared, pi r squared. Okay, so that's the area of the top and the bottom. And there's 2 of them. So pi r squared, so circle pi r squared. Now, here's that shape, all right? And I know from the other page that when I unravel this stuff, I'm going to have two circles with the paper in between. Two circles with a rectangle, right? Now, this part here. Do you agree that this side leg here is the height of my cylinder? I go and I cut this cylinder open, and look what I have. How would I find the area of this? What is the shape here that I have? It's a square rectangle looking thing, right? How would I find that? Okay, there's right angles, so it's just going to be length times width, right? Length times width for that part that is right here. So it's going to be length times width. However, what is the length or the width of this? Okay? The height, I before E. Nope. Height is equal to the width and the length is equal to the circumference. It is equal to the circumference. Because look, here's my water bottle. Here's my paper fitting around my water bottle. Here's this side right here. David, hold on to that edge right there. Hold on like this. Okay? Do you agree that this part that he's holding on to is the circumference of the circle? Yes, you should. Okay? No, keep hold of it. Now look at the part that he's holding on to. That edge, hold it up so everybody behind you can see it higher. You're going to have to lift your arm. The part that he's holding on to right here, that was the circumference of the circle, and that's going to be our length. Thank you. Does that make sense? Okay? So that's the circumference. So I'm going to need to take the height, which equals the width, length is the circumference. So curved surface is going to be, what is the, so it's going to be height multiplied by, how do you find the circumference of a circle? Go for it.
Radius
Close. What's that? Pi r, 2 pi r. 2 pi r or pi r2. I'm going to do 2 pi r. Height multiplied by 2 pi r. Got it? Yay, we get to try it. So I know that I have to do the height times 2 pi r to get the circle, or to get the side, and I know that I have to do pi r squared multiplied by 2 to get the two sides, because that's what we just did. So, oh, wrong way. So what is that going to look like? We have 2.2, which is our radius, right? Yes? Yes. So we are going to substitute those in there. We have 5 as the height. We have 2, and we have a pi, and we have the radius, which is times 2.2. Who's got a calculator with them right now out? Let's do that. 5 times 2 pi multiplied by 2.2. All right, what do you have, sir?
34.55.
We're going to round up. Is that what you got? You what?
So is it 5 times 2, then you times 10 times 5?
Sure. You do 5 times 2 times pi times 2.2 equals. What'd you get? 69.1? Is that what you got? I think you forgot to do this too here. Let's see where this is. It's not low, it's high. Oops. All right, so it's 69 point what? 69.1. All right, then this one, pi r squared 2, is going to be listed as pi r, which is 2.2 squared times 2. Which equals, what'd you get there? 30.4. I need one more person to verify that. Cameron? Okay. 30.4. Add these two puppies together. 99.5 centimeters squared. Surface area of cylinder is 99.2 or 99.5 centimeters squared. Has to be centimeters squared. We have to be in 2 dimensions here, folks. We are unfolding a 3-dimensional object into 2 different ones. Okay, let's see if we can zip through this because I'm making my fourth period do it. Now we have 6 sides here. We have 6 sides, but we only have 2 different lengths. But 3 different side lengths. We have sides 1, side groups 2, and side groups 3. We have sides that are 4 by 5, and there's 2 of them. We have sides that are 6 by 5, and there's 2 of them. We have sides that are, what's the last side that we haven't taken care of? We have 4 by 5, 6 by 5, and what? Yeah. Yeah, 6 by 4. And there's 2 of them. So 20 times 2 is 40. 6 times 5 is 60, plus times 2 is 60. 6 times 4 is 24, times 2 is 48. Inches squared. So this side here is the 4 by 5. Okay. This side right here is the 6 by 5. And this side right here is the 6 by 4. Okay, do you agree? Any questions on that? Yes. Okay, just a stretch. All right. Last melon. So we have a triangular prism here. We only have 5 sides, and we have these symbols here, which indicates what? Britain. Not only isosceles, but this is an equilateral triangle. Okay, this is an equilateral triangle. So we have, to get the formula, because the surface area of a triangle is going to be 1/2 base times height. But what do we have up top? When I'm looking at my notes while I do my homework like a good student does, I'm going to look up here and see that this is what I need to pay attention to. Okay, in my notes. Don't pack up your stuff yet. We have 4 minutes. I hear you rustling. So it is just going to be base times height for that triangle, which is what? What's the base times the height of that triangle? 24. Because 8 times 3 equals 24. Then we have the surface area, which is length times width. And there's 3 of them. They're all going to be the same size. So I have 8 times 12 times 3. 8 times 12 means the distributive property. 8 times 10 is 80. Plus 16 is 96. Then 96 times 3 is very close to 100 times 3. 100 times 3 is 300. Take away 12, 288. That was 302 centimeters squared, and boom goes the dynamite. We finished that. 3, 4. 2, 3, 4. 5. 2, 3, 4, 5. You know, I didn't tell fourth period, so no. 4.